when we met, we actually did this production simulation and came up with this data for making paper links. And now we're going to take some production information, specifically this typical data, and we are going to use it to arrive at cost curve data. So just to review for a moment, in the short run, capital resources are fixed. So the fixed resources in the short run were the desk, the scissors, and the stapler, and you had just one unit of each. Over time, we continued to add more and more units of labor, and so what we were looking for was what is the relationship between units of labor and output. So as we added each unit of labor, what happened to total output or total product, what happened to marginal product, and what happened to average product. Now what we're going to do is we're going to say, okay, we have all that data, and we're going to put it in this bigger table. You can see, if you want to look back, it's actually exactly the same information. So each time we add a worker, right, we add to total product and marginal product. And I took the average product off here because we're not going to use that right now. And now we're going to throw in some cost information. So I want you to assume that fixed resources cost $30 for each production period. And it doesn't change because the fixed resources have a fixed cost. And each worker costs $12 per production period, and that is a variable expense. So it costs more if you have more workers. So now we can add new columns. And I want you to think about each one as we go. I'm going to show you what goes in them, but I bet you can figure out exactly what goes in each one. So total fixed costs with just one unit would be what? It'd be $30 because I told you the fixed costs are $30. So what about if we have I'm sorry, that was with one unit of fixed resources but no variable resources. So what if we add variable resources? Well, it's still $30, right? If we have two workers, still $30, and so on. Because our fixed resources stay constant, so the fixed costs stay constant. Now we're going to look at what happens to our variable costs. Look back up. I told you each worker costs $12 per production period. So if we have no workers, our variable costs would be nothing. What about if we hire one worker? $12. I'm going to give you a second. You should pause and fill in the rest of this column. So each time, each worker adds the variable cost of $12. Total cost column, all we're going to do is we're going to add together our fixed costs and our variable costs. So the total cost with no workers is $30. With one worker, 42. Okay, again, you should pause and make sure that you know how to fill in the rest of this. I will show you what it is. Okay, now we get to the two columns that we have not seen before. Average total cost and marginal cost. Average total cost is a very simple calculation. You take total cost and you divide it by total product. So the blue column divided by the total product column. $30 divided by no product, right? We can't calculate. But $42 divided by 5 units of output tells us $8.40 is the average cost of each paper link when we have one worker and we're producing 5 paper links. So what will happen if we add another worker? Now we spent $54 and our total product was $11. Okay, it dropped pretty significantly. Why? Because we're spreading the fixed costs out over more units of output, and because the second worker was actually more efficient than the first. So our total cost dropped. Here, our total product is 15, so $66 divided by 15. And we can see what happens. As we add additional workers and produce additional output, our average total costs drop for a while. But then they start to go back up. And the reason for that is because the additional workers are becoming less efficient, right? So even though we're spreading the fixed costs out over more people, the additional workers are less efficient. Marginal cost is the trickiest one in this and probably the very most important for economics. Marginal cost, again, we can't calculate it with no workers. It's the cost not of the next worker. We know that, right? The next worker is $12. We already know that. That's not very interesting. The marginal cost is the cost of the next unit of output. So what does it cost to produce just one more paper link? So what we need to figure out is what is the change in cost as we move from one line to the next, from this line to this line, and what is the change in output? So as we go from no workers to one worker, our total cost changes by $12. Notice we could also do this with variable costs, right? Our total cost changes by $12. Our output changes by 5, so it's $12 divided by 5. That's the marginal cost of one more. What gets left out when you're doing marginal cost is fixed cost, because it doesn't matter, right? Whether we produce 1 unit of paper links or 20 unit of paper links. The fixed costs are the same, so they don't factor into the marginal cost of one more. All right, here, again, total cost change by $12. My variable cost change by $12. We're going to divide that by not total product, but by the change in output. Okay, we spent $12 more, and we got 6 more paper links, so the marginal cost was 2. When we hired the third worker, we spent $12 more, and we got 4 more paper links, so the change is 3. Fourth worker, we spent $12 more, we only got 3 more links. So see what's happening? Because the workers are not producing very much, but they cost the same, the marginal cost of production starts to go up. So that's a very fundamental concept in economics, that in the short run, you're going to have diminishing marginal productivity over here, and you're going to have rising marginal costs. Here I moved the columns so you can get a little bit better look at the relationship here. Total variable costs, you can see them next to average variable cost, right? Total variable, average variable, total variable, average variable, and you can see total and average total. Okay, so that's just to show you what's happening as we increase output. If you were to graph that data, you would get a graph that looks something like this. Okay, as we saw, marginal costs drop quickly, and then they rise for a long time and steeply. Average total costs drop for a long time, and then they also start to rise. Average variable costs drop for a while, not for quite as long as average total costs. Look at this. Average variable costs are dropping, but they start to turn around by the time we have this fourth worker, where average total costs don't start to go up until the fifth worker. Because average total costs, you're still getting the gains of spreading the fixed costs out over more, whereas that doesn't affect average variable costs. And then average fixed costs, you can see they just fall over time, and they're actually not usually going to show up on the graph. So there's a few key points on this graph. One is that average fixed cost is the distance, right, between average total and average variable cost. And you'll notice that if you go over here too. I think I put average fixed cost on here. Yeah. If you take average total cost and you subtract average variable cost, you get average fixed cost. Why? Because fixed plus variable equals total, so average fixed plus average variable must equal average total. Okay. Two other important things here. You'll notice that the marginal cost curve crosses both ATC and AVC at their low points. That's because if the marginal cost of producing the next unit is higher than the average cost right now, it's going to pull up the average. So it's just like if you're in a class and your quiz scores, you've got an 80% average on quizzes, and the next quiz you get 100, it's going to pull up your average, right? That's why you work hard on the next quiz. So if your average cost of production is $3 and the marginal cost of one more is $4, it's going to start to pull up your average. So MC is going to cross both of these at their low point. No relevance for AFC because it's just spreading out over a higher and higher quantity of goods. All right, diminishing marginal productivity and rising marginal costs are a short-run phenomenon brought on by the fact that the firm can't increase the plant size. So you're trying to crowd more and more workers and more variable resources into a fixed plant size. In the long run, firms can increase their capital. They can increase their plant size. We made the paper links on one little table. In the long run, we wouldn't be limited. We could turn every table in this classroom over into producing paper links. We could turn the whole school over. We could turn the whole city over into producing paper links, right? There's no limit in the long run. So in the long run, what you have is a series of different possible ATC curves based on factory size, okay, or based on plant size. So each of these would have its own marginal cost curve, its own average variable cost curve, but we're not going to graph all those here. It would get very messy. So this is one option, to have a very small factory, right? And you can see that you don't have to produce very many units of output before average total costs start going up. So this might be, for example, a very small bottling plant for a local, like Jones Soda Company, right? And if they want to expand their output, they're not very smart to expand it in that firm, right? Because average total costs are going to rise. They'd be better off to expand or open a new bottling plant, and the new bottling plant gives them a new ATC, right? And now they can expand all the way out to here and see their costs decrease. But again, they're still going to be limited, right? They're still going to be limited. It's not an infinite growth pattern, that larger one. So all of these represent different sizes of factories that the soda company could choose from. And what's the right ATC curve depends on how much soda they want to produce, right? This one looks great because it's so low cost. But this ATC curve wouldn't be very good if you were only producing this many units, right? Because the average total cost would be enormous over there. It says here, initially the firm achieves economies of scale. That means as they get bigger, they become more efficient, and the low point of the ATC curve is lower. We'll see in a second what diseconomies of scale look like. Wait, I thought we would see it. Guess I got out of order. Okay, sorry, I thought I had that on here. So I guess there's not the graph for diseconomies of scale here. What diseconomies of scale would look like, if you can follow this cursor for a moment, economies of scale are when the ATC is dropping as you expand output. Diseconomies of scale would be when it starts to go back up. So rather than calling that diminishing marginal returns, it's diseconomies of scale, and it's not caused by being in the short run with a limited factory size. What it is caused by is inefficiencies of getting too large. So breakdowns in communication, too many department chairs. It gets very difficult to communicate within a firm of greater than 150 people. So duplication of effort, right? Things get lost, big bureaucracies. All right, what I am going to do is talk just briefly about labor markets to finish up this day. So labor supply is an upward sloping line, and the labor supply, like any other supply, right, there's more labor supplied if the labor is getting paid more. And this P we would actually probably replace with a W, okay, wages. So what makes people want to work? What can make them not want to work? Higher pay definitely brings more people into the labor market, which is why this is upward sloped. But this labor supply curve is going to be different for different jobs. So a job that's very, very difficult and requires a lot of training, like being a surgeon, the supply curve is going to be over here. Okay, because training, if a job requires a lot of training, a lot of people can't do it, right? So very few people would do it. A job that's very easy and anybody could do it, like, you know, walking dogs, the supply curve of labor would be further to the right because there's a lot more people qualified. There are some jobs, however, that are very easy to do, but they're very gross and people don't like them, like cleaning bathrooms. So that one would be more to the left. Even though it's relatively easy to do, the ick factor keeps people away. All right, so what determines the demand for labor and what makes a firm want to hire workers? We know what the supply is. So I want you to, I put this in here because we're just going to refer right back to this, right? When we made paper links, we had this table just the other day, right? We had total product, we had marginal product. Now we're going to throw in something else, which is the price of the product. So if the price of the product is $2, now we can actually take this marginal product data and we can calculate the revenue from selling this product. So let's imagine the paper links sell for $2 a piece. The total revenue, if you hire one worker and they produce 7 paper links, right, and you sell them for $2 a piece, you get $14 in revenue. And for the firm, that gives them a $14, what we call marginal revenue product. It's the money they earn off of hiring that one worker. If you hire another worker, their marginal output is 6. Product price is 12, right? So even though total revenue is 26, you sold 13 at a price of $2 a piece. Marginal revenue product is only $12 because that's what you got, right, from that additional worker. So marginal revenue product is essentially how much is this worker worth to me? What is the value of the output they can produce? And if you continue to fill this in, you'll see this would be a 10, right? And this would be 8, and this would be 6, and this would be 4. So let's imagine that this is 10, 8, 6, 4, and I tell you you have to pay your workers at least $10. Who are you going to hire? Well, you're certainly going to hire somebody who adds $14 to your revenue because you only have to pay them 10, so that's profit for you. You're also going to hire the person who adds $12. Economists agree that you would hire the break-even person, but you wouldn't hire anybody else. So if the wage was $10, you'd hire 3 people. All right, so you can look at this, and I'm going to encourage you to work through this yourself, and then we can go over this problem when you come to our next meeting.